Okay, here's a problem from 2.7, limits at infinity. Problem 30. The limit as t goes to negative infinity of 4 plus 6 times e to the 2t over 5 minus 9 e to the 3t. Now, probably it would be wise to sort of refresh our memory on what does the graph of y equals e to the t look like. Well, looks like that. E to the 0 is 1. E to the 1 is e, or 2.7, right? 1 comma 2.7, right? And there's also there's a horizontal asymptote at the negative side. The horizontal asymptote is y equals 0. And in sort of algebra terms, in calculus terms, we'd say the limit as t goes to negative infinity of e to the t equals 0, right? So as it gets closer and closer. Well, what happens when you have e to the 2t? Well, a 2 right next to t is a horizontal compression. So still e to the 0 is 0. E to the 1/2 would now be 2.7. So it compresses this, but the point is this limit would still be the same. Same for e to the 3t. So what happens here is, oops, I don't need to write limit. You can see that actually what happens is this term right here is going to 0. So when each of the individual terms exists, you can actually apply the limit to each. So 4 is 4, 6 is 6, this is going to 0, 5 is 5, 9 is 9, this is going to 0. Sometimes people put arrows through it and say this is going to 0, that's going to 0, but the point is this comes out to 4/5. Okay? Well, you might say that's great, but what I'm really concerned about is what happens when these things start shooting off and the individual terms aren't 0. So 2 problems for the price of 1. Let's imagine the problem had been what happens as we go to infinity. Now, this term is shooting off to infinity. Also, this term is shooting off to infinity. Well, now we have an indeterminate form, infinity over infinity, infinity over negative infinity, I guess. But what do you do about that? Well, I take the largest term in the denominator and I try to cancel it. So you might write 1 over e to the 3t, or if you're being fancy, you can write e to the negative 3t, same thing. You have to multiply by the same thing, numerator and denominator, so I'm stuck multiplying my numerator by 1 over 3t. Let's sort of see what happens. Limit as t goes to infinity of, well, here I've got 4 over e to the 3t. The nice thing is this is going to 0. Numerator's fixed, denominator's going to infinity. This term right here, e to the 2t over e to the 3t is 6 over e to the t, right? So what do you do with exponents? You subtract, so 2t minus 3t is minus t, or put it in the denominator. This term has 5 over e to the 3t, and this has 9. That's why I use the largest power in the denominator. Now, that goes to 0, that goes to 0, that goes to 0. That stays at negative 9, so you have 0 plus 0 over 0 minus 9. That's 0.